On October 21st, 2024, 44 of the world's leading climate scientists signed a letter that should have made front-page news everywhere. Instead, most people never heard about it. Addressed to the governments of Northern Europe, its message was blunt. A system of ocean currents that has kept Europe habitable for 10,000 years is showing signs of imminent collapse, and almost nobody is prepared. Among the signatories was Michael Mann, Presidential Distinguished Professor and Director of the Penn Center for Science, Sustainability, and the Media, one of the most respected climate scientists alive. He and his colleagues warned that the danger has been severely underestimated and demanded immediate action. Read that again. Not warming, not melting, collapse. And the terrifying part is that the very thing causing it is the same thing making headlines every summer: record-breaking heat. To understand why a warming planet could trigger a sudden and brutal cold snap, you first need to understand just how strange 2024 really was. It was the hottest year ever recorded on Earth. Not the hottest in a decade, the hottest since we began keeping records. Australia baked under temperatures of 50.7 degrees Celsius. Canada hit 49.6 degrees. In Mexico, the mercury climbed to a staggering 52 degrees Celsius, a number that sounds less like weather and more like a setting on a survival simulator. While the Northern Hemisphere cooked, the Amazon, the largest and most water-rich river system on the planet, began visibly shrinking, its tributaries running dry in places that had never seen a dry season like it. On the other side of the globe, in Antarctica, a glacier so dangerous, scientists nicknamed it the Doomsday Glacier, was quietly falling apart, shedding roughly 50 billion tons of ice every single year. That is enough meltwater to fill 20 million Olympic swimming pools annually. This glacier alone, if it fully collapsed, could raise global sea levels by nearly 10 feet, enough to redraw the map of every coastal city on Earth. So here's the question nobody wants to ask out loud. If the planet is this hot, why are scientists suddenly obsessing over the possibility of an ice age? Which is it going to be? Unbearable heat or brutal freezing cold? The uncomfortable answer, according to researchers across the globe, is both, just in different places and possibly within our own lifetimes. Part of the planet may be heading toward a localized deep freeze, while another part sinks slowly beneath rising seas. This isn't tabloid speculation. It's the real, peer-reviewed conclusion being reached independently by oceanographers, climatologists, and paleoclimate researchers who study how Earth's climate has behaved for hundreds of millions of years. The key to this paradox lies in a strange patch of ocean near Greenland. While practically every square mile of ocean on Earth has been warming for the past century, this one region has stubbornly done the opposite. It has been cooling year after year, even as the rest of the planet breaks heat records. Scientists call it the cold blob, and it sits directly along the path of one of the most important ocean currents on the planet, a current responsible for keeping an entire continent's climate mild. That current is part of a massive engine called the Atlantic Meridional Overturning Circulation, or AMOC. You've probably heard of one piece of it before: the Gulf Stream, the very reason London gets more rain than sunshine, despite sitting at a latitude further north than most of Canada. Here's how the system works. Warm surface water near the equator absorbs heat from the sun and begins a long journey north and south, carrying that warmth to distant continents. By the time it reaches the frigid waters near Greenland and the Arctic, it has cooled, become denser and saltier, and sinks deep into the ocean, where it flows back toward the equator to begin the cycle again. This process has run like clockwork for roughly 10,000 years, and it is the single biggest reason Europe enjoys a mild climate, despite sitting at the same latitude as much of Canada and Siberia. Without it, London would feel more like Labrador. But the cold blob near Greenland is telling scientists that this ancient conveyor belt is starting to jam. The cause traces back to melting ice. As Greenland's glaciers melt at an accelerating rate, they dump enormous volumes of fresh water into the North Atlantic. Fresh water is lighter than salt water, so instead of sinking and driving the circulation forward, it simply floats on the surface, stalling the entire system. Warm surface water can't cool and sink the way it's supposed to, so the engine that pumps heat from the tropics to the poles begins to sputter. This isn't the first time it's happened. Researchers studying ice cores and ocean sediment have found that this current has weakened or shut down entirely several times over the past 100,000 years, and every single time, the consequence was sudden, dramatic cooling in Europe. The most famous example happened roughly 12 to 900 years ago, at the end of the last ice age. A massive glacial lake in North America called Lake Agassiz, likely destabilized by a comet impact, suddenly released an enormous pulse of fresh meltwater into the Atlantic. The circulation collapsed almost overnight in geological terms, and Europe was plunged into a savage cold snap known as the Younger Dryas. This wasn't a bad winter. It lasted approximately 1,300 years, an abrupt, localized ice age that gripped the continent for over a millennium, all triggered by a disruption to a single ocean current. Today, scientists are watching the same warning signs reappear, except this time the trigger isn't a shattered glacial lake, it's us. According to the scientists behind that October 2024 letter, if current greenhouse gas emissions continue unchecked, temperatures in parts of Europe could plunge by 5 to 15 degrees Celsius within just a few decades of a full collapse. Some climate models suggest the first serious symptoms could begin appearing as early as the 2060s, while other, more aggressive models put the timeline as early as the 2070s. A separate 2023 study published by Danish researchers Peter and Suzanne Ditlevsen used centuries of sea surface temperature data to estimate that a collapse could plausibly occur anywhere between the years 2025 and 2095, with the most likely window centering around the middle of this century. In other words, some of the people reading this today could live to see the beginning of it. To put the current state of warming in perspective, consider the numbers the World Meteorological Organization has been tracking. Since the start of the Industrial Revolution, Earth's average global temperature has climbed by roughly 1.5 degrees Celsius, bringing the planetary average to around 17 degrees Celsius. That might sound trivial, like a mild spring afternoon, but remember this isn't the temperature of one city on one day. It's the average across the entire surface of the planet, oceans included. A rise like that is the equivalent of a human body temperature spiking from a healthy 37 degrees to nearly 38.5. You could survive it, technically, but your entire system would be under visible strain. That is exactly what's happening to Earth's climate right now. Glaciers retreating, ocean currents faltering, droughts and floods becoming more extreme and more frequent. The driving force behind all of this is the greenhouse effect, the trapping of heat by gases released through industrial activity, deforestation, and fossil fuel extraction. For a preview of what an extreme runaway version looks like, look at Venus. Its atmosphere is so thick with carbon dioxide and sulfuric acid that heat from the sun gets trapped permanently, unable to radiate back into space, leaving surface temperatures around 470 degrees Celsius, hot enough to melt lead. Earth is nowhere near that scenario, but the comparison shows just how sensitive a planet's climate is to its atmosphere's composition. Now picture something that seems to contradict everything you just read. A snowstorm so severe it strands drivers on a highway overnight, dumping over 6.5 feet of snow in days. Sounds like a routine Canadian winter, right? This actually happened in South Africa last September. Cold air masses that normally stay locked over Antarctica occasionally surge northward, producing anomalies like this. Rare today, but climatologists warn scenes like this could become far more common and severe across Europe if the Atlantic circulation keeps weakening, not as a freak storm, but as the new normal for centuries. The consequences of an AMOC collapse wouldn't stop at freezing European winters. The U.S. East Coast could be hit almost as hard in the opposite way. Warm water from the tropical Atlantic and Caribbean normally flows north along the U.S. coast before crossing to Europe as part of the same circulation. If that circulation breaks down, this warm water simply pools off the American coastline, and because warm water expands and takes up more volume than cold water, this creates a localized sea level rise, independent of ice melt, estimated at an additional 2 to 3 feet. Miami, southern Florida, Manhattan, Brooklyn, and the New Jersey shoreline would all face chronic flooding and breached storm defenses. Warmer coastal waters also mean more fuel for hurricanes, since storms draw their power directly from ocean heat. Climatologists warn that even historic disasters like Hurricane Katrina in 2005, which devastated New Orleans, or Hurricane Sandy in 2012, which flooded New York City and cut power to millions, could be dwarfed by the storms this new climate regime is capable of producing. If all of this sounds like the plot of an overproduced disaster film, multiple independent research groups agree this trajectory is plausible by 2100 if emissions aren't brought under control. Some places won't even get the chance to wait that long. Tuvalu, a tiny Polynesian island nation of roughly 59,000 people across just 70 square miles, saw its prime minister record an address for the 2021 UN Climate Conference while standing knee-deep in seawater. His message was simple: we are sinking. The country's highest point sits just 14.5 feet above sea level, and large portions already sit 2 to 3 feet below the waterline at high tide. Tuvalu may become the first nation in modern history to be erased entirely by rising seas. Faced with catastrophes on this scale, some scientists have proposed radical interventions. Take the Thwaites Glacier again, that doomsday glacier in Antarctica. It spans roughly 46,000 square miles, comparable to Pennsylvania, and is responsible for approximately 4% of all current global sea level rise on its own. Around 80% of icebergs in the southern oceans originated as fragments of it. Engineers have proposed a massive underwater barrier of overlapping plastic or fiber curtains anchored to the seafloor, stretching 50 miles across the entrance to the Amundsen Sea and rising 2,000 feet to block warm currents from eroding the glacier from below. Estimated price tag, roughly $80 billion, about 8 times the cost of the James Webb Space Telescope. In Switzerland, engineers have already tested a simpler idea on a smaller scale, covering glaciers with reflective blankets to bounce sunlight away. Wrapped glaciers melt roughly 70% slower than unprotected ice. Most scientists are candid about the limitations of such fixes. Building a barrier around one glacier while global industry keeps pumping out greenhouse gases is a bit like trying to stop a car with failed brakes by opening a window. In 2021 alone, industrial activity in China released an estimated 1.5 million tons of greenhouse gases every single hour, roughly what 1.5 billion cars would emit in that time. Emissions have effectively become an unofficial marker of national wealth and power, which is part of why global emissions have proven so difficult to reduce despite decades of climate summits. Here's where the story takes an unexpected turn. To understand what might come next, it helps to understand that Earth has never stopped cycling between warm and cold extremes, and in a strange technical sense, we are already living inside an ice age right now. Geologists define an ice age as any period when at least one of Earth's poles is covered in a permanent ice sheet. And by that definition, we've been in one for roughly 2.6 million years. What we're actually experiencing right now is a warmer stretch within that larger ice age, called an interglacial period. And when interglacial periods end, the deep cold returns in force. Scientists reconstruct this ancient climate history by drilling ice cores from Greenland and Antarctica, preserving roughly 800,000 years of atmospheric data trapped in tiny air bubbles, and by analyzing ocean floor sediment, which stretches the record back tens of millions of years further. Rock formations push the picture back even further. The very first known glaciation, the Huronian Ice Age, began approximately 2.4 billion years ago, triggered when primitive algae began releasing oxygen that broke down methane, a potent greenhouse gas, while the sun itself burned roughly 15% dimmer than it does today. Earth stayed locked in ice for nearly 300 million years. Far more brutal was the Cryogenian period, beginning around 720 million years ago, nicknamed Snowball Earth. Even at the equator, temperatures rarely climbed above negative 20 degrees Celsius, while much of the planet sat below negative 50. Oceans are believed to have frozen solid to their depths, and at the poles, dry ice, solid carbon dioxide, formed on top of ordinary water ice. From space, Earth likely resembled Saturn's icy moon Enceladus, whose surface reflects 99% of incoming sunlight. Only isolated pockets of bacteria and algae clinging to volcanic hot springs are believed to have survived. Later came the Andean-Saharan Ice Age, roughly 450 million years ago, lasting about 30 million years and far milder by comparison, though still severe enough to end catastrophically. As it thawed, many scientists believe frozen methane deposits destabilized and erupted into the atmosphere in what's called a methane bomb, displacing oxygen and triggering the deadliest mass extinction in Earth's history, the end Permian extinction, which wiped out roughly 70% of land species and 96% of marine species. So what actually controls these massive swings between deep freeze and warmth? One factor is fluctuation in solar activity itself. American physicist Robert Ehrlich built computer models of solar plasma behavior and found its natural cycles line up closely with the timing of Earth's glaciations. Interstellar dust clouds can also partially block sunlight from reaching us. Another major factor is Earth's own orbital geometry, described by the astronomical model developed by Serbian scientist Milutin Milankovic. His calculations track how the tilt of Earth's axis, influenced by the gravitational pull of the Moon and other planets, cycles roughly every 26,000 and 41,000 years, while the shape of Earth's orbit around the Sun stretches and compresses on a roughly 93,000-year rhythm. When axial tilt, orbital shape, and solar output all line up unfavorably at once, the planet can receive 5 to 10% less solar energy than usual. Ice sheets expand under those conditions, and since ice reflects sunlight rather than absorbing it, the cooling effect snowballs, reinforcing itself over thousands of years. Volcanic eruptions add another layer, since ash and sulfur blasted into the upper atmosphere can block sunlight for years, while shifting continental plates and mountain building gradually pull carbon dioxide out of the atmosphere through rock weathering. This combination of forces produced the most recent major ice age, which began roughly 35 million years ago in the Cenozoic era, our current geological era, featuring a repeating rhythm of intense glacial periods and milder interglacial stretches. We currently sit inside one such interglacial period, the Holocene, which has lasted about 11,700 years. Even within it, temperatures have swung significantly. The most recent serious cold snap, the Little Ice Age, gripped the world from roughly the 14th through the 19th century and is considered the coldest stretch in the past 2,000 years. Researchers have directly linked its onset around the year 1300 to a slowdown in the Gulf Stream, The resulting harsh, wet growing seasons across Europe destroyed crops and triggered the Great Famine, which killed millions. Full glacial cycles have historically returned roughly every 10,000 years, and by that clock, we are arguably overdue. So why hasn't the next ice age begun? Many researchers believe humanity has pumped so much greenhouse gas into the atmosphere that we've inadvertently held the natural cooling cycle at bay, a delay that might last another century, or by some estimates, another 1,000 years. Strangely, some scientists believe our current warming could actually be nudging the next ice age closer. As Arctic sea ice melts and exposes open water, that water evaporates more readily and falls as snow across subpolar regions, feeding new glaciers, until the warm Gulf Stream eventually loses the strength to push through these expanding ice barriers, allowing ice sheets to spread rapidly. If a full-scale glaciation like the last one, which ended roughly 10,000 years ago, were to return, Earth's surface would become almost unrecognizable. Massive ice sheets carved in compressed mountain ranges, scoured away topsoil and locked up so much water that sea levels dropped dramatically, exposing land bridges now separated by ocean. Canada, Scandinavia, the British Isles, and much of northeastern Europe and Russia sat buried under ice sheets kilometers thick. Models suggest equatorial temperatures could fall by roughly 10 degrees Celsius, with northern and southern regions plunging to around -50. Crop failure on that scale would trigger famine echoing what followed the eruption of the Toba supervolcano, roughly 74,000 years ago, an event some researchers believe reduced humanity to as few as 2,500 survivors. The geopolitical map would be redrawn just as dramatically as the physical one. Scientists estimate ocean levels could drop by as much as 150 meters in a full glacial maximum, reconnecting Sri Lanka to mainland India, merging the Indonesian archipelago into a single landmass, and linking Ethiopia to Yemen across what is now open sea. Existing ports would become useless as coastlines retreat. Florida, Southern California, and much of the southern United States could take on a climate closer to present-day Alaska, destroying grain production almost immediately, while Australia, New Guinea, Sub-Saharan Africa, and Southeast Asia might retain climates suitable for agriculture, potentially turning countries like India and Brazil into agricultural superpowers. Whether those regions could realistically feed billions of climate refugees is a question many experts believe would end in conflict rather than cooperation. Humanity isn't entirely without ideas for fighting back, however unconventional. Some scientists have floated deliberately introducing potent greenhouse gases like chlorofluorocarbons to counteract severe cooling, essentially engineering a controlled greenhouse effect as a defensive measure. Fusion energy systems designed for extreme Arctic conditions could theoretically power frozen population centers, while others have proposed harvesting energy from glaciers themselves, using rail-mounted turbines to capture meltwater cascading down mile-high ice walls. Genetic engineering could also produce cold-resistant crops capable of surviving shortened growing seasons, echoing the resilience Arctic populations like the Inuit have shown for centuries without any of this technology. There's also a real possibility that the next major climate shift doesn't take the form of a dramatic ice age at all. Some researchers point to a different scenario entirely. A planet increasingly coated in pollution particles, thick enough to block substantial sunlight from reaching the surface while simultaneously trapping heat within the lower atmosphere, effectively creating a world that's cold and dark near the ground but wrapped in a warm, polluted shell above, something like a baked Alaska in reverse. Which scenario actually plays out first remains genuinely uncertain, and researchers continue to debate it using an ever-growing library of ice core, sediment, and satellite data. One more piece of this puzzle sits much closer to home, literally orbiting us. The Moon, at just over a quarter of Earth's diameter, is unusually large relative to its host planet, and its gravitational pull does far more than create tides. Roughly every 18.6 years, the Moon's orbit undergoes a subtle wobble, first documented back in 1728. Half of this cycle slightly suppresses high tides. The other half amplifies them. According to NASA, the Moon is currently approaching the amplifying half of that cycle, and combined with accelerating sea level rise, researchers project coastal cities worldwide could see dramatically increased flooding starting around 2030, persisting for roughly a decade. Back in 2014, global sea levels sat about 3 inches above the 1993 average, rising roughly 1/8 of an inch per year. That rate has since accelerated to approximately 4.8 millimeters annually, according to NASA's Jet Propulsion Laboratory, driven largely by faster ice loss from Greenland. The Moon's influence doesn't stop at tides. Its gravitational pull creates subtle bulges in Earth's atmosphere as well as its oceans, and scientists have found this can measurably influence rainfall patterns, and even contributes marginal shifts to systems like El Niño, the Pacific climate pattern driven by shifting warm water and wind patterns. Satellite data has even detected a slight rise in polar atmospheric temperature, around 0.5 degrees Celsius, during full moon phases. The effects are small individually, but layered on top of an already destabilized climate system, they add another unpredictable variable. With nearly 40% of the U.S. population living in densely populated coastal regions, and 8 of the world's 10 largest cities near coastlines, the stakes of getting this wrong are almost incalculable. Recent history offers a preview of what's already possible, even without a full AMOC collapse. In 2021, catastrophic flooding struck multiple continents within months of each other. Extreme rainfall along Australia's east coast triggered the worst flooding New South Wales had seen in 60 years, forcing more than 18,000 evacuations and causing upwards of $1 billion in damage. Western Germany and eastern Belgium were hit by flash floods after roughly 150 millimeters of rain fell near Cologne in a single day, more than double July's average, while parts of Belgium recorded over 270 millimeters in 48 hours, a national record. In the Belgian town of Dinant, floodwaters swept parked cars down city streets. More than 200 people died, one of Europe's deadliest floods in a century, and meteorologists had predicted it 9 days in advance, yet evacuations largely failed to materialize in time. That same year, central China endured its heaviest rainfall in 1,000 years, with Zhengzhou receiving roughly 20 centimeters in a single hour, flooding subway tunnels and stranding passengers underground. Turkey faced catastrophic mudslides and flash floods, with helicopter rescues pulling villagers off rooftops, even while simultaneously battling heat waves exceeding 50 degrees Celsius and some of its worst wildfires in over a decade. North America wasn't spared either. In Lytton, British Columbia, temperatures spiked to an almost unbelievable 49.6 degrees Celsius, and within days, the entire town was destroyed by a wildfire fueled by the heat. Portland, Oregon, soared to 46 degrees Celsius, unheard of for its mild, rainy climate. Wildfires raged across Siberia that year, releasing an estimated 505 megatons of carbon dioxide, while California's Dixie Fire became one of the largest single wildfires in the state's history. Even under optimistic, low-emission projections, scientists estimate global sea levels will rise at least 30 centimeters above year 2000 levels by 2100. Under a true worst-case scenario, where all of Earth's land ice eventually melts, seas could rise by roughly 70 meters, enough to submerge nearly every coastal city and reach well inland, high enough to touch the raised elbow of the Statue of Liberty. There's a small note of reassurance buried in the data, however. The Antarctic ice sheet, which holds the majority of Earth's frozen fresh water, has survived far warmer periods before. Roughly 125,000 years ago, during the last major interglacial, global temperatures were similar to today's, and sea levels sat only 4 to 6 meters higher, not 70, suggesting total, immediate collapse isn't the most likely near-term outcome, even if a partial and dangerous rise absolutely is. Taken together, the picture that emerges isn't a simple story of a planet just getting hotter. It's a planet whose most fundamental climate systems, the ocean currents that regulate heat, the ice sheets that reflect sunlight, and the orbital and lunar rhythms shaping weather from the background, are all being pushed simultaneously by forces we've unleashed and forces we can't control. Whether the next major shift arrives as scorching heat, catastrophic flooding, a localized deep freeze across Europe, or some combination the models haven't fully anticipated yet, the message from researchers is consistent. The window for calm, gradual adjustment is closing, and the choices made in the next few decades will determine which version of this future unfolds. Earth has swung between fire and ice for billions of years before humans existed, and it will keep doing so long after. The only real question is whether we'll be ready when the pendulum swings again.